submission. Okay. So firstly, this machine learning is a subset of artificial intelligence which provide machines the ability to learn automatically and improve from the experience without being explicitly programmed. So but this statement shows right here. So generally the machine will learn from the experience. You can say right here, machine will learn from the experience, and we are not programming that particular model. Okay, we are just giving the input for different data sets of images, and we train the model with the help of those images, and with the some experience from previous data sets, it will automatically classify what that image shows. Okay, so you can see this image right here. A child is looking on these images, and he is trying to find out what that image will show. Okay, so right here he will not understand, okay, what is that image. So we have to tell them, or we have to tell him that this image belong to orange, this image belong to apple, and this image belong to cherry. So similar process we have to perform in case of machine also. We have different images of different fruits, and we provide those images to the computer, and that computer holds some algorithm, and that algorithm will learn the patterns of those images, and that will classify automatically what that image contain. Okay, so generally this machine learning is divided into three types. First one is a supervised learning, second one is unsupervised learning, and third type is a reinforcement learning. As you can see, supervised learning is a method in which we teach the machine using labeled data set. You can see this image right here. Teacher is explaining what that figure contains, and students are learning when teachers told them that this image belong to that particular type of category. Okay, so similar process we have to follow in case of machines also. We have to tell the machine that this particular image belong to uh, apple category, this image belong to banana category, this image belong to any other fruit category. Okay, so this particular process is called a supervised learning, in which we know the labels of those images. Okay, second type is unsupervised learning, where you have to learn by yourself, and you have to represent your knowledge, okay, based on the patterns which you learn over the time, okay, over the experience. So in unsupervised learning, the machine is trained on unlabeled data without any guidance. So we don't know what that particular image contain. So machine automatically learn the pattern, and it will show the output. Whereas in the reinforcement learning, agent will perform some task based on some reward and penalty based. Okay, so you can see right here, in reinforcement learning, an agent interact with its environment by producing actions and discover errors and or rewards. So you place this agent in an environment, and automatically this agent will learn from the environment. Okay, if it will perform a wrong thing, then you penalize that agent. If that agent will perform correctly, then you reward that particular agent. Okay, so this is called a reinforcement learning. So in supervised learning, generally two type of algorithms are used. One is a regression, and second one is a classification. Regression algorithm is a continuous data processing. Okay, so you can see there is a weather prediction. Okay, so how this weather prediction is happened nowadays very accurately, because we have data of previous years, and we analyze that data, and we predict what is going to happen in next few days. Okay, based on the real inputs, or previous data, you can predict what is going to happen in next few days, okay, through this regression algorithm. Second algorithm, it has a classification. You have seen in your email, there is one spam folder, there is one inbox folder, okay. So automatically this email receive in the spam. So how this automatic process for receiving email into spam, it identifies some keywords from the email. Let's suppose that inside that email, one keyword is written that you won that much money in a lottery. If you pay that much amount, then you will get this lottery in your account. So automatically this email identify these keywords and put that particular email into a spam folder, okay. So this category is a binary category. Either you will give output as a 1, or you will give the output as a 0, okay. 1 is a true and 0 is a false, okay. So this is a binary classification, whereas in regression you deal with continuous data, whereas in supervised learning, unsupervised learning, there is no label. So if that image contain no label, then how this model or this learning algorithm will find which image category it belong to? So it identify the patterns inside the image. Let's suppose that you are giving 100 images of apple and 100 images of mango, okay. So automatically this algorithm identify the feature of mango and apple. There is a shape difference between mango and apple, okay. So you can segregate these mangoes and apple in the form of clusters, okay. You form some clusters related to mango, and you form some cluster related to apple, and automatically this unsupervised learning will cluster these two categories into different clusters, okay. Here you can see the reinforcement learning. This agent is placed inside this game, and if it collide at particular position, then you give this agent as a negative 1 point as a penalty. If it reach a final destination, you will give this agent a plus 100 point for the reward. So it understand, if I collide at this particular obstacle, I will be penalized, and if I will reach a final destination, I will be rewarded. So this type of learning is used in Tesla cars, okay. So you can see right here how you can perform the task on the different data sets. In the supervised learning, you know the image and you know the label of that image. So both these labels and image are known to you, and you provide those to the algorithm, and algorithm automatically classify which one of the input category is, okay. So here you will get the output as a cat image, okay. But you can see in the unsupervised learning there is no label, okay. Only image is available, no label is there. So how this algorithm will classify? This algorithm will extract some feature of the cat. So shape of the cat is different, shape of dog is different, okay. The tail is longer in case of cat, tail is shorter in case of dog. The ear is also longer in case of dog, whereas in case of cat it is smaller, okay. So there are so many features it identify, and it cluster these images into different clusters, and it classify those cluster as category A and category B, okay. So this is unsupervised learning, whereas this reinforcement learning, you can say this is an agent. You can place this agent in an open environment. When this agent will perform some wrong task, you give him a penalty. If it perform a right thing, then you give him a reward, okay. So this is a reinforcement learning. Okay, so how you can perform the training? Right here you can see supervisor is there, big brother of this boy is here to train him the baseball game. Okay, so some trainer is there to perform the task in supervised learning, whereas in unsupervised learning, the person need to perform the task by himself, and it will identify the patterns to get the output. Whereas in case of reinforcement learning, we don't know the anything. If you perform the right thing, then we will get a positive response or positive reward. If we will uh, do the wrong thing, then we will be penalized at that particular point. Okay, so this is a reinforcement learning, and our aim is to provide these algorithm for real time problems. So here you can see this supervised learning is used as a regression and classification, and you can real time give the output for weather prediction. You can give real time output for this market prediction. Okay, which share is going to be increasing and which share is going to be falling in 10 minutes or 1 hour or in 1 day or 1 week or 6 months. You can give the prediction according to the data. Whereas in unsupervised learning, we discover, identify, or understand the patterns of the images, and we have to predict those formation. And in case of reinforcement learning, we learn series of action, and based on error hit and trial methods, we perform these tasks to generate the patterns. Okay, so how we can apply these approaches to perform the operations? In supervised learning, we map the labeled input to the known output, and this labeled input is provided to the training data set, and this algorithm will learn from this labeled data as well as the input image, and it will give you the output, known output. Okay, so why it will give you the known output? Because you know the label as well as the image inside that particular data. Okay, whereas in unsupervised learning, this will understand the pattern and discover the output. We don't know the labels of the image, so it understand the patterns and the feature of that image, and it will explore those patterns, and through this algorithm it will give you the output. Whereas in reinforcement learning, based on reward and penalty, it will learn the process and give the output. Okay, so which are the algorithm used in these three type of learning process? Generally we will use linear regression, logistic regression, sport vector machine, k nearest neighbors, random forest for supervised learning. Whereas for unsupervised learning, we are using clustering algorithm like k-mean clustering algorithm, upright clustering algorithm, c-mean clustering algorithm. So all these are clustering algorithm. They find the patterns inside the image and give the output. Whereas in case of reinforcement learning, we will provide the q-learning and sars learning for the algorithm and get the final output. Okay, so here in supervised learning, we evaluate the risk and we forecast the sales. Whereas in unsupervised learning, we will provide some recommendation system, and we can also detect anomaly. Okay, so how you will give the recommendation? You can say there is a Amazon website. When you purchase one item, let's suppose that you purchase cricket bat. So when you purchase cricket bat, it recommend you can purchase plastic ball, you can purchase some type of casio balls. Okay, so different recommendation it will provide you. If someone buy milk, then it will give recommendation to buy bread, or buy another product similar to that category. Okay, so it will also give anomaly detection. So what do you mean by anomaly? Anomaly means anything unusual to the daily routine. So let's suppose that any transaction you are performing throughout a year is below 5 to 10 lakh rupees. But one day when you perform 1 crore transaction, so this machine learning algorithm automatically identify that this person is transferring 1 crore rupees per day, but throughout the year he is not able to transfer 5 to 10 lakh rupees. Okay, so that is anomaly detection. Okay, clear. Then reinforcement learning is used in self-driving cars and gaming. So you have seen Tesla cars. In Tesla cars, this car is equipped with so many sensors. Okay, so these sensors will receive real-time environment conditions, and these sensors signal will be provided to the machine learning model, and this model will give the decision to rotate the wheel, okay, in right direction, left direction, or make some break when obstacle arrive near to that car. Okay, so in gaming, this reinforcement learning is also used when this particular car is moving from one point to the another point. When it collide at particular point, we will give this car as a penalty, and when it reach the final destination, we will provide this car as a reward. Okay, so in term of points, we will provide reward and penalty. Okay, so how the process of this supervised learning will follow: initially we will provide some data, and we will choose the random sampling for that particular data, and we divide that data into two parts. 70% we are using for the training, whereas 30% we are using for the testing. Okay, so when you train the model, machine learning model, with 70% data, all the features of those images will be stored inside this statistical model. When you perform some testing data, these features are compared with the prediction and validation model, and it will give you some accuracy. Okay, and this model will validate at that particular point. So your model is to be divided into three parts. First is a predefined steps, which is represented by black arrow, and there is a blue color arrow which represent the training process, and red color arrow represent the validation. So validation is used when you perform some accuracy measure. Training is used when you want to train your model with the existing data, and pre-processing or predefined steps are there uh, when you want to rearrange your data. Okay, so the prediction model give at the prediction model, when you provide a new data set, all the stored data set or statistical model is available with you. You compare with the new data and give the prediction, and you will get the predicted outcomes of your model. Okay, so this is the flow of a supervised learning model, and how you will get the accuracy of your model. These are the steps. First, we will perform the training using the training data set. Then you perform the testing using the test data set. Then we will calculate how many correct classification we have achieved over a total number of cases. So you will calculate this accuracy using this formula, and this training data set is given to the learning algorithm that will learn the patterns and store those patterns inside this model. After storing the patterns, we provide the testing data, and we compare the images with the pre-trained model, and it will give you accuracy how many number of correct classification will be appearing over total number of cases. Okay, so this is this PyCaret library, and how to access all the data sets which are available inside this PyCaret library. Okay, so first of all, what you have to do, you have to install the PyCaret. Okay, so how you will install the PyCaret? Use pip install PyCaret. Okay, use pip install PyCaret. Okay, so if you use this command pip install PyCaret, your PyCaret library will be installed inside your Google Colab. Okay. So all of you, have you installed this PyCaret library inside the Google Colab? Quickly give your response in chat. Quickly give your response in chat. Have you installed this PyCaret library? Pip install PyCaret. Okay, so it is installing inside the Google Colab right here. You will see all the library is going to be installed inside Google Colab. After installation, we have to extract the data sets which are available inside this PyCaret library. Okay, so how to get all these data sets which are available inside this PyCaret library. So what we will do from PyCaret library, we will access all the data sets. Okay, we will access all the data sets. So what you will do, I am sharing this code with you inside your chat. Okay, you can copy this code from the chat. Okay, and understand this first. What we are doing right here, we are using from PyCaret.dataset. So PyCaret is a library. Okay, inside this library all the data sets are available. So we are calling this data sets. Okay, and we import this get underscore data. So this get underscore data hold all the data sets. Okay, so what we are doing right here, we are defining a variable data sets, and inside this variable what we are using, we are using a function get underscore data, and we are putting index values right here. Okay, so automatically all the data sets which are available inside the PyCaret, they will be shown right here. Okay, so how many data sets are there? Total 55 data sets are there, you can see right here. Okay, so all the data set will be displayed right here, and you will see these are the dataset: anomaly detection, France dataset, Germany, bank, blood, cancer, credit, diabetes. So we will use any one of the dataset to explore what we are going to perform with the help of this. Okay, so diabetes dataset represent right here. We will use this dataset to explore for the classification. You will see this is a classification type of data set. Generally it has a binary classes, either that is 0 or 1. Okay, and you will see this data set is a clustering type of data set. Facebook data set is there, jewelry data set is there, migration data set, all are clustering based. So we don't know the labels in clustering. Okay, whereas in classification you know the labels. In regression you will see this is a regression. Regression is also a supervised learning problem. You know the labels. Okay, you know the labels right here. So this is a supervised learning, whereas clustering is not a supervised, it is a unsupervised learning. Okay, so this p by caret library hold three type of data set. One is classification, second one is regression, and third one is clustering. Okay, so after extracting all the data sets, what we are going to do, we will perform the classification. Okay, for this particular data set. So for that we have to find the type of this data set, what this data set contain. Okay, this data set contain the data frames. Okay, you will see right here this data set contain a data frame. So what is data frame? Data frame is nothing but a combination of columns and rows. Okay, so all the rows and columns are combined together right here. So this is the data set which contain all the rows and columns right here. Okay, then we will read the columns from this data set. So what we are doing right here, we are using this variable diabetes data set, and after this we use dot operator to call the columns. Okay, so after this you will find all the columns related to this diabetes dataset will be present right here. This is the column number 1. Okay, you will see right here number of time pregnant. This is the second column, plasma glucose concentration. This is the second column. This Systolic blood pressure is the third column. Okay, so you will see all the columns right here. After defining these columns, we have to use the describe function. With the help of this describe function, we will get all the columns details in terms of mean, median, mod, then 75% of data, 50% of data. So what we are doing right here, this is the variable name, diabetes dataset. After this we will use the dot operator and we will use the describe option. Okay, so when you use this describe option, it will give you the column statics. Okay, you will see the column statics right here. So total 768 columns are there. Its mean is 3.84 for this number of time pregnant. Okay, standard deviation is 3.36 for this number of time pregnant. Minimum value is 0.0, 25% value is 1, and 50% value is 3, and 75% value is 6, and maximum value is 17. So in this manner, this whole the columns will represent all the mean, median, mode, standard deviations, minimum value, maximum values, and all these values right here. Okay, after this we have to perform the classification. Okay, after this we have to perform the classification. What is classification? Classification is the prediction. Okay, between those values that particular person belong to diabetic or non-diabetic behavior. Okay, so what we are doing right here, we are using this PyCaret classification model, and we use the setup data for this dataset, diabetic dataset, and we set a target variable as a class variable, and we will put it as a silent equal to true. Okay, after performing this, you will find that all the data set is going to be executed with different parameters right here. Okay, so session id, target values, all these parameters will be executed right here. And after that we have to compare our model, classification model, with other models. Okay, so for that we are using compare model method. Okay, so you use the variable compare and you will call the compare model function and execute it. And here you will see the initialization process, status of tenfold validation, and estimator is your random forest classification. Different estimators are there. Okay, ada boost estimator is there, extra tree classifier is there. Okay, for each of these models it is generating accuracies. Okay, right here. So you will see after this which model is generating good accuracy. So GBC is a gradient boosting classifier which give you 77.46 accuracy, which is best among the others. Okay,